All right, guys, today we're going to be taking a look at conditional statements. That's what CS stands for here. Conditional statement, often referred to as an if-then statement. All right, we're talking about if a certain condition exists, then we have a resulting idea coming out of it. You see this in many different subjects, including science, where a lot of times this initial condition is actually referred to as a hypothesis. Here in geometry, we call it the same thing, hypothesis, or sometimes we would just use the letter P. All right, this resulting scenario, if we have a hypothesis in science, that would be referred to as the conclusion or resulting idea, conclusion. Or we would possibly use the letter Q. So we would talk about if P, then Q, if we were looking for symbolism. So the conditional statement, sometimes if we want to break it down to just symbolism, we would have a P, then an arrow, then a Q. We'd be talking about if P, then Q. For this statement, if a shape is a triangle, then it has three sides. So you would also be asked to address the validity of this statement. So we'd be asked, is this true in every possible case? Or can we think of a scenario or a counterexample where it would be false? In this case, if you have a shape and it's a triangle, it's going to have three sides. That's always the case. But what we're talking about right now is certainly in the category of logical reasoning. We want to be able to mess with some of these logical statements and evaluate them over and over and over and really mess with the situation and reconsider its validity. So one thing that we might do is we might take a conditional statement like this and we might alter it. We could write what's called the converse of a conditional statement. All right. Well, it's easy to try and symbolize this using the symbolism we just used before. A converse. Instead of writing if P then Q, we're going to try write if Q then P. All right, so the hypothesis P, the conclusion Q, they need to switch. And we need to write a sentence that our English teachers are going to be proud of. Now notice, the hypothesis does not include the word if, the conclusion does not include the word then. Those items stay right where they are. So, but when I bring the conclusion over here, the English teachers would be very upset with us if we led a sentence with a pronoun we have yet to identify. So in this sentence, what we're talking about, it is a shape, so I would adjust just a little. If a shape has three sides, then, now I can use the pronoun, then it is a triangle. So we've just switched the hypothesis and conclusion. We have a new sentence, and we would, again, is this going to be true in every case, or is this going to be false? Now we're going to readdress and relook at the scenario. If a shape has three sides, then it's a triangle. This is also always true. All right, so let's try and mess with it again. Another way to mess with a sentence like this is we could write what's called an inverse. So again, we're always trying to adjust the original conditional statement, reevaluate its validity. Well, to write an inverse, this is some interesting symbolism. We're going to use this squiggle. We're not going to move the hypothesis. We're not going to move the conclusion, but I've put this squiggle in there, and that means we're going to negate or say the opposite of the hypothesis and conclusion. Now, let's make sure we understand the English language very well. The opposite of a triangle is not a quadrilateral, all right? If you want to say the opposite of something, if I don't want to move the hypothesis, I just want to say the opposite, I would just throw the word not in there. And again, we want to make our English teachers proud. So if I'm going to write an inverse, I would say, and again, I'm not moving the hypothesis, I just want to say the opposite. So instead of a shape is a triangle, I'm going to say if a shape is not a triangle. And I got to do the same thing for the conclusion. Then it, now I got to make the English sound good. I don't want to say it not has three sides. That doesn't, our English teachers would be very upset with us. Then it doesn't. I can adjust some of the words so that the English sounds good. Then it doesn't have three sides. All right. Now again, if a shape is not a triangle, then it doesn't have three sides. If we're talking about the validity, true or false, it just so happens we're still true here. That's true in every case. All right. And the last way to manipulate these sentences and reevaluate them is called a contrapositive. Really long word, positive. And that really long word kind of makes sense. We're actually going to combine the converse and the inverse. We're going to try and do if not Q, then not P. So we negated both of them, but we also want to switch them. So our sentence is going to be, and again, we got to work out the English here. Instead of saying if it has three sides, I'm going to say if the shape does not have three sides. If the shape does not have three sides, then it is not I'm going to just draw a triangle. I'm thinking whether this is true in every case or possibly false. If shape does not have three sides, it is not a triangle. That is going to be true again. All right. So this is a way to look at conditional statements, manipulate them, and constantly readdressing the validity of each statement. Are they true in every single possible case, or is it possible that they're false? All right. Here's one way, and since we have the last kind of way to look at this would be to look at what's called a biconditional. So these words, there's a lot of words. You're going to have to study these words. A biconditional can only be written if the original conditional statement and the converse are both true, which was the case with what we just wrote. This is often the best way to write a good definition. Biconditionals are used to write quality definitions. And here's the way we do it. I'm going to take the conditional statement that we had before. The hypothesis was a shape is a triangle. I'm going to go ahead and just put the shape there. A shape is a triangle. And our conclusion was it has three sides. The way that you write a biconditional, notice I did not put in if or then. The additional piece that you have to put in to write a biconditional are these words: if and only if. So the sentence, the biconditional, And again, the only reason I was able to write a biconditional is because the conditional statement and the converse were both true. So the way this would read, a shape is a triangle if and only if it has three sides. This is actually the quality rate way to define a triangle. And the only reason we were able to do it, again, the conditional and the converse were both true. All right. So lastly, I showed you a bunch of true statements. All right. What if I showed you one? I'll give you a hint. This one's false. If my shape has four sides, then it is a square. So on a quiz or a test, first I might ask you, hey, what's the hypothesis? You would want to only underline this portion. I might ask you to underline with one line hypothesis, with 2 lines the conclusion. Notice I did not include the word if. That's not part of the hypothesis. The conclusion, it is a square. I did not underline the word then. That's not part of the conclusion or the hypothesis. Those are kind of our setup words. And I gave you a hint. We're talking about true or false. There is at least one case where this is false. On the quiz or a test, if you say false, I would want you to identify a counter example. So this would be a good time to think. Is it possible? Can we think of something that does have 4 sides but is not a square? And if you're thinking, you're trying to get your mind going and thinking about all those things, there's a bunch of possible answers. You can say a rectangle, a trapezoid, a rhombus, a kite. I'm just going to choose something simple, like a rectangle. Rectangle has 4 sides, but it's not necessarily a square. A rectangle is a counterexample to this situation. All right, so you're going to be tasked with writing some sentences and evaluating the validity of a bunch of them. So again, if you need to, come look at this video again and go over the symbolism that you'd need to memorize. There's some good symbolism here for each one. And remember what it takes to write a biconditional. And here's even an example of one conditional statement that's false. All right. Thanks for listening.